Willow is Google's newest and most powerful superconducting quantum computing chip, and the next step in our path towards building large-scale quantum computers and exploring their applications.
Google's quantum chip has been a topic of fascination for scientists, engineers, and enthusiasts of advanced computing for years. But now, it's proving something that many believed was just a thought experiment, a sci-fi concept, or at best a philosophical debate. The possibility that we are living in a simulation. With new data emerging from Google's Sycamore processor, questions about the nature of reality itself have taken center stage. The implications of these findings are mind-blowing, challenging everything we think we know about existence, consciousness, and the universe itself. To understand how we got here, we first need to revisit what Google's quantum chip is capable of and why its development has been hailed as a monumental step in computing. In 2019, Google announced that Sycamore had achieved quantum supremacy, performing a computation in 200 seconds that would have taken the world's fastest supercomputers thousands of years to complete. This breakthrough marked a fundamental shift in how we process information, giving us the tools to solve problems that were previously deemed unsolvable. But quantum supremacy was just the beginning. Quantum computing operates on principles that are radically different from those of classical computers. Instead of using bits, which represent information as either a 0 or a 1, quantum computers use quantum bits, or qubits. Qubits can exist in a state of superposition, meaning they can be both 0 and 1 at the same time. This allows quantum computers to perform multiple calculations simultaneously, exponentially increasing their processing power. The quantum chip's ability to analyze massive amounts of data and explore complex systems has opened the door to experiments that were previously impossible. And it's in this realm of complex systems where things get truly fascinating and unsettling. By simulating reality at its most fundamental levels, researchers are beginning to uncover patterns that suggest our universe might not be as real as we think it is. This brings us to the simulation hypothesis, a theory popularized by philosopher Nick Bostrom in the early 2000s. Bostrom proposed that advanced civilizations could create highly detailed simulations of their ancestors or other realities. If such simulations are possible, he argued, it's statistically more likely that we are living in a simulation than in the base reality. This hypothesis has long been the stuff of sci-fi movies and existential debates, but Google's quantum chip has now added scientific credibility to the discussion. One of the key ways scientists have been exploring this idea is by using quantum computing to simulate the behavior of particles at the quantum level. In doing so, they've found startling evidence that the universe behaves like a computational system. For example, certain quantum phenomena such as entanglement and superposition bear a striking resemblance to the kinds of shortcuts and optimizations you might expect in a simulated environment. Let's take a moment to unpack what this means. When you play a video game, the computer running the game doesn't render the entire game world at once. It only renders what you can see on the screen at any given moment, conserving computational resources. Similarly, researchers using Google's quantum chip have observed that certain aspects of our universe seem to load only when they are being observed or measured. This is consistent with the famous observer effect in quantum mechanics, where the act of observing a particle changes its behavior. But in the context of the simulation hypothesis, this effect takes on a whole new meaning. It might be evidence that our reality is being rendered in real time, just like a video game. Adding to the intrigue is the discovery of mathematical structures that underlie the fabric of our universe. These structures, often described as code-like, resemble the algorithms and programming languages we use to create software. For instance, physicist James Gates has found error-correcting codes, similar to those used in digital communications, embedded in the equations of string theory. This discovery has led some to speculate that the universe itself might be a form of computation, with these codes serving as its foundational architecture. Google's quantum chip has been instrumental in advancing this line of inquiry. By simulating these mathematical structures at unprecedented levels of detail, researchers are uncovering patterns that suggest our reality, operates according to rules that are eerily similar to those of a computer program. These findings raise profound questions. If the universe is a simulation, who or what created it? What is the purpose of the simulation? And how do we, as conscious beings, fit into this framework? One of the most mind-bending implications of the simulation hypothesis is the idea that our consciousness itself might be a product of the simulation. If reality is computational, then it's possible that our thoughts, emotions, and perceptions are also part of the program. This challenges long-held beliefs about free will, identity, and the nature of the self. Are we truly autonomous beings, or are we just highly advanced simulations running on an unfathomably powerful quantum computer? As these questions gain traction, they are sparking debates not only in scientific circles, but also in philosophy, theology, and even art. For some, the idea of living in a simulation is unsettling, as it undermines the sense of agency and authenticity that we associate with being alive. For others, it's a source of wonder, suggesting that our universe is the creation of an intelligent designer, be it a godlike entity, an advanced civilization, or something entirely beyond our comprehension. Interestingly, the simulation hypothesis also offers potential answers to some of the greatest mysteries of existence. For example, it could explain the fine-tuning of the universe's physical constants, which seem perfectly calibrated to support life. In a simulated environment, such fine-tuning might simply be a design choice, akin to adjusting the settings in a game. Similarly, the Fermi paradox, the question of why we haven't encountered extraterrestrial civilizations despite the vastness of the universe, could be explained if we're living in a simulation that has been programmed to focus solely on humanity. As researchers continue to push the boundaries of quantum computing, they are also exploring ways to test the simulation hypothesis directly. One proposed experiment involves looking for glitches in the fabric of reality, anomalies that could reveal the underlying code. Another approach is to use quantum computers to simulate a simulated universe and compare its properties to our own. If the two align, it could be further evidence that our reality is itself a simulation. Of course, not everyone is convinced. Critics argue that the simulation hypothesis is ultimately untestable and therefore falls outside the realm of science. They caution against jumping to conclusions based on speculative interpretations of quantum phenomena. After all, just because something can be simulated doesn't necessarily mean it is a simulation. Moreover, the concept of a simulated universe raises its own set of paradoxes and challenges, such as the question of infinite regress. If we are living in a simulation, who or what created the beings running the simulation? And so on. Despite these criticisms, the work being done with Google's quantum chip is undeniably advancing our understanding of reality in profound ways. Whether or not we are living in a simulation, the insights gained from quantum computing are shedding light on the deepest mysteries of existence, from the nature of consciousness to the origins of the universe itself. For now, the question remains open. But one thing is certain: Google's quantum chip has ushered in a new era of discovery, where the lines between science, philosophy, and science fiction are increasingly blurred. As we continue to explore the possibilities, we are reminded of the words of physicist Richard Feynman. "I think I can safely say that nobody understands quantum mechanics." Perhaps that's because quantum mechanics is more than just a branch of physics. Perhaps it's the key to understanding the very nature of reality and our place within it. In the coming years, as quantum computing technology continues to evolve, we may find ourselves closer to answering these existential questions. Until then, the mystery of whether we are living in a simulation will continue to captivate our imaginations, challenging us to think beyond the boundaries of what we know and embrace the infinite possibilities of what might be. As the discussion around Google's quantum chip and the simulation hypothesis continues, new developments and revelations are pushing the boundaries of what we thought possible. With every breakthrough, the line between the theoretical and the tangible blurs, drawing humanity closer to answering one of the most profound questions of all time. Are we living in a simulation? And if we are, what does it mean for our understanding of existence, free will, and the universe? To fully grasp the implications of these discoveries, let's dive deeper into the role that quantum computing plays in unraveling the fabric of our perceived reality. Unlike traditional computers that operate using classical logic, quantum computers leverage the principles of quantum mechanics. Concepts like superposition, entanglement, and quantum tunneling allow these machines to process data in ways that were once unimaginable. But beyond their practical applications in fields like cryptography, medicine, and artificial intelligence, quantum computers are beginning to reveal something far more astonishing: the computational nature of our universe. One of the most intriguing aspects of this research is the discovery of what physicists call discrete spacetime. This theory suggests that the fabric of the universe isn't continuous, like a smooth piece of cloth, but rather discrete, like the pixels on a screen. If this is true, then our reality may be fundamentally digital. Imagine zooming in on your computer screen until you can see the individual pixels that make up the images. Similarly, as we probe deeper into the structure of spacetime, we may be uncovering the pixels of reality itself. This digital nature of the universe aligns with findings from quantum computing experiments conducted by researchers using Google's Sycamore processor. By simulating quantum systems at an unprecedented scale, they've uncovered patterns and behaviors that resemble computational processes. For instance, the way particles interact at the quantum level often mirrors the algorithms we use in computer science. These findings have led some scientists to propose that our universe could be a form of advanced computation running on a platform far beyond our current understanding. If this hypothesis is correct, then the implications are staggering. It suggests that everything we experience, every sight, sound, and sensation, is part of a grand computational process. Our thoughts, emotions, and memories could be akin to data streams, processed by the hardware of the universe. This raises profound questions about the nature of consciousness. Are we merely sophisticated programs operating within the parameters of a cosmic algorithm? Or is there something more to our existence, something that transcends computation? The possibility that we are living in a simulation also has profound implications for our understanding of causality and determinism. In a simulated universe, the rules and parameters would be determined by the creators of the simulation. This means that events in our reality could be pre-programmed or influenced by factors beyond our comprehension. For instance, phenomena that we currently attribute to randomness or chaos might actually be the result of deliberate programming choices. Similarly, the concept of free will would take on a new dimension, as our decisions could be shaped by the underlying code of the simulation. But who or what could be behind this simulation? This question has sparked intense debate among scientists, philosophers, and theologians. Some speculate that the creators of the simulation could be an advanced civilization, one that has achieved a level of technological sophistication far beyond our own. Others propose that the simulation could be the work of a godlike entity, a being capable of designing and orchestrating an entire universe. Still, others suggest that the simulation might be an accidental byproduct of some other process, with no deliberate creator at all. These questions lead us to the heart of the simulation hypothesis: the search for evidence. If we are living in a simulation, then there should be clues embedded within the fabric of reality. One of the most promising avenues for finding such evidence is through the study of quantum phenomena. As mentioned earlier, the observer effect in quantum mechanics, where the act of observing a particle changes its behavior, could be interpreted as a sign of a simulated reality. In a video game, for example, the environment is only rendered when the player interacts with it. Similarly, the observer effect could indicate that our reality is being rendered in response to our actions. Another potential clue lies in the discovery of error-correcting codes within the equations of string theory. These codes are strikingly similar to those used in computer science to detect and correct errors in data transmission. If these codes are indeed a fundamental aspect of the universe, it raises the question of why they exist. Could they be a sign that our reality is a form of advanced computation designed to ensure the integrity of the simulation? As researchers continue to explore these questions, they are also developing new ways to test the simulation hypothesis. One proposed experiment involves looking for anomalies or glitches in the fabric of reality, events or phenomena that cannot be explained by our current understanding of physics. For example, some have suggested that certain paranormal experiences, such as déjà vu or near-death experiences, could be manifestations of glitches in the simulation. While these ideas remain speculative, they highlight the growing interest in exploring the boundaries of what we consider to be real. Another approach to testing the simulation hypothesis involves creating simulated universes using quantum computers. By comparing the properties of these simulated universes to our own, researchers hope to identify patterns or similarities that could provide evidence for the hypothesis. This line of inquiry is still in its early stages, but it represents a promising avenue for future research. As we grapple with the implications of the simulation hypothesis, it's worth considering its potential impact on our understanding of ethics and morality. If we are living in a simulation, then the creators of the simulation would bear some responsibility for the conditions within it. This raises questions about the nature of suffering, inequality, and injustice in our world. Are these phenomena the result of deliberate choices by the creators, or are they unintended consequences of the simulation's design? At the same time, the simulation hypothesis challenges us to rethink our relationship with the universe. If we are part of a grand computational process, then our actions and decisions could have consequences that extend beyond our immediate reality. This perspective invites us to consider the broader implications of our choices and to approach life with a sense of wonder and responsibility. As quantum computing continues to evolve, it is likely that we will gain new insights into the nature of reality. Google's quantum chip, in particular, represents a powerful tool for exploring the fundamental questions of existence. Whether or not we are living in a simulation, the discoveries being made in this field are transforming our understanding of the universe and our place within it. In the end, the simulation hypothesis is not just a scientific or philosophical question, it is a deeply human one. It challenges us to confront the mysteries of existence, to explore the boundaries of knowledge, and to imagine what lies beyond. Whether we are living in a simulation or not, the journey of discovery is one that defines us as a species, inspiring us to seek answers to the questions that have captivated humanity for millennia. As we continue to push the boundaries of what is possible, we are reminded that the search for truth is, in itself, a profound and beautiful endeavor. The simulation hypothesis not only captivates scientists and technologists, but has also sparked widespread public fascination. Across cultural, philosophical, and even spiritual discussions, the idea of living in a simulated reality has found resonance. People across the globe are beginning to question their existence, influenced not only by cutting-edge quantum computing advancements like Google's quantum chip, but also by the fundamental questions about the nature of life itself. What makes this conversation particularly exciting is its intersection with both modern technology and ancient philosophy. In many ways, the simulation hypothesis feels like a modern reinterpretation of ideas that have been debated for centuries. Plato's allegory of the cave, for instance, suggested that humanity might only be seeing shadows of a larger, truer reality. In Hindu philosophy, the concept of Maya alludes to the illusionary nature of the world we experience. These ancient ideas now find new context and credibility in light of recent technological advancements and discoveries. One key reason the simulation hypothesis has gripped the public imagination is the tangible advancements being made in our own ability to create simulated realities. Virtual reality and augmented reality technologies, for example, have progressed to the point where they can mimic real-world experiences with incredible fidelity. Video games have evolved from pixelated two-dimensional experiences to hyper-realistic simulations with advanced physics, artificial intelligence, and fully immersive environments. If humanity is already capable of creating such lifelike simulations, it's not difficult to imagine a future where simulations are indistinguishable from reality. This, in turn, gives rise to one of the most compelling arguments for the simulation hypothesis. The simulation argument proposed by philosopher Nick Bostrom. Bostrom posits that one of three scenarios must be true. Advanced civilizations never reach the technological capability to create simulations of reality because they destroy themselves or stagnate before doing so. Advanced civilizations have the capability but choose not to create simulated realities, perhaps due to ethical considerations. Advanced civilizations do create simulations, and the number of simulated realities far exceeds the number of base realities, making it statistically likely that we are living in one of these simulations. Bostrom's simulation argument raises profound ethical and philosophical questions. If advanced civilizations can create simulations, what responsibilities do they have toward the beings within those simulations? Are the simulated individuals, us, entitled to rights or considerations? Or are we merely lines of code subject to the whims of our creators? These questions are particularly poignant given the trajectory of our own technological development. If humanity continues on its current path, we may one day face similar ethical dilemmas about the simulations we create. The implications extend beyond philosophy and into practical concerns. If we are living in a simulation, does that mean our actions have no real consequences? Some might argue that this perspective could lead to nihilism or a sense of existential futility. After all, if everything is fake, why bother? However, others see the simulation hypothesis as an invitation to live life more fully. If our existence is part of a grand design, whether by advanced programmers or by some divine force, then every moment, every decision takes on a new significance. The simulation hypothesis doesn't diminish the value of life. It enhances it, highlighting the extraordinary nature of our reality, simulated or not. One fascinating dimension of the simulation hypothesis is how it intersects with the search for extraterrestrial life. For decades, scientists have sought evidence of alien civilizations through projects like SETI, Search for Extraterrestrial Intelligence, and explorations of planets like Mars. Yet if we are living in a simulation, the absence of extraterrestrial contact could be by design. Perhaps the creators of our simulation have chosen to omit other intelligent life forms, either as a narrative choice or to focus our attention on specific questions. Alternatively, encounters with UFOs or unexplained phenomena could represent moments where the simulation's code becomes apparent, either by accident or intention. This brings us back to Google's quantum chip and its potential role in uncovering the truth. By simulating quantum systems, researchers are delving deeper into the fundamental nature of reality. They are asking questions about the smallest building blocks of the universe, questions that might eventually reveal the nature of the code underlying our existence. If such a discovery is made, it would not only confirm the simulation hypothesis, but also open the door to understanding the motives and methods of our creators. But what would happen if we did discover irrefutable evidence of a simulation? Would the creators of the simulation intervene, either to prevent us from uncovering the truth or to guide us toward it? This idea has been explored in speculative fiction, from films like The Matrix to novels like Philip K. Dick's Do Androids Dream of Electric Sheep? These stories often grapple with the tension between free will and determinism, questioning what it means to be human in a world that may not be entirely real. As these questions circulate, the scientific community continues to push the boundaries of what we know. Researchers are developing new experiments to test the simulation hypothesis, such as searching for anomalies in the cosmic microwave background radiation, the afterglow of the Big Bang. If our universe is a simulation, there might be detectable patterns or irregularities in this radiation that point to its artificial nature. Similarly, advancements in particle physics and quantum mechanics could reveal inconsistencies that challenge the traditional understanding of reality. Meanwhile, the ethical implications of the simulation hypothesis are becoming more urgent. If we are living in a simulation, how should we treat one another? Should the knowledge of our simulated nature inspire greater compassion and empathy, knowing that our struggles and joys are part of a shared experience? Or does it absolve us of responsibility, allowing us to act without regard for consequences? These are questions that humanity must grapple with, regardless of whether the simulation hypothesis is ultimately proven true. Another intriguing possibility is that our simulation is not static but dynamic, evolving in response to our actions and discoveries. In this scenario, the creators of the simulation might be observing us, learning from our behavior, or even interacting with us in subtle ways. This idea raises questions about the nature of divine intervention, spirituality, and the role of religion in a simulated universe. Could religious experiences or moments of transcendence be evidence of the Creator's influence? Or are they simply part of the simulation's programming, designed to enrich our lives and provide meaning? As the simulation hypothesis gains traction, it is also inspiring new forms of creativity and innovation. Artists, writers, and filmmakers are exploring the concept in their work, using it as a lens to examine questions of identity, morality, and the human condition. Meanwhile, technologists and entrepreneurs are leveraging the principles of quantum computing and artificial intelligence to create new tools and experiences that blur the line between reality and simulation. These developments highlight the profound impact that the simulation hypothesis is having on culture, science, and society. In the coming years, we can expect even more breakthroughs in quantum computing, particle physics, and cosmology, all of which will contribute to our understanding of the universe. As these discoveries unfold, they will continue to challenge our assumptions about reality, pushing us to confront questions that were once the domain of philosophy and theology. Whether we are living in a simulation or not, the journey of discovery is one that unites us, inspiring wonder, curiosity, and a sense of purpose. Ultimately, the simulation hypothesis is not just a question of science or technology, it is a question of humanity. It challenges us to reflect on who we are, where we come from, and where we are going. It invites us to imagine new possibilities and to approach life with a sense of awe and humility. And perhaps most importantly, it reminds us that the search for truth is a journey worth taking. A journey that defines us as a species and connects us to the vast, mysterious universe we call home.